Deep beneath the mountains of Switzerland, inside the labyrinth housing the world's most powerful particle accelerator, something unprecedented has occurred. Scientists at CERN claim they've established communication with an object that shouldn't be capable of responding. This is an active, intelligent signal originating from 3I Atlas, a celestial wanderer drifting through the darkness between stars. For the first time in human existence, something from beyond our solar neighborhood has initiated contact. The interstellar visitor that silently passed Mars has apparently been listening, waiting, and now responding. If authentic, this represents the threshold moment when humanity transitions from cosmic isolation to confirmed membership in a universe teeming with intelligence. When scientists first detected 3I Atlas approaching from the constellation of Atlas, trajectory calculations revealed something extraordinary. The orbital path wasn't elliptical like objects native to our solar system. It was hyperbolic, stamped with the unmistakable signature of interstellar origin. This visitor originated somewhere in the immense void between star systems, traveling for potentially millions of years before encountering our Sun's gravitational influence. The color stereo surface imaging system aboard Mars Express wasn't designed for hunting comets. Engineers built this camera to photograph Martian geology in exquisite detail. Every calibration had been optimized for stationary landscapes. Asking this instrument to track a rapidly moving object, millions of kilometers away through absolute darkness, was like demanding a microscope to function as a telescope mission controllers. Devised an improvised technique called step-and-stare imaging. The spacecraft would reorient slightly, capture a 5-second exposure, then reorient again. Each photograph aimed at the predicted future position of the comet. During those critical seconds, 3I Atlas raced tens of kilometers across the field of view, while the spacecraft itself orbited Mars. The resulting raw images looked catastrophic, filled with streaks, noise spikes, cosmic ray impacts, and hot pixels. The breakthrough emerged through mathematical processing. When dozens of these seemingly useless images were precisely aligned and digitally stacked together, a faint elongated glow materialized from the chaos. The signal brightened exactly where theoretical models suggested. Its directional movement matched orbital calculations with stunning accuracy. Scientists were witnessing authentic photons reflected from an object that originated beyond our Sun's domain. The high-resolution stereo camera joined the observation campaign despite even more severe limitations. Its maximum exposure of half a second had been chosen to prevent motion blur when photographing Martian surfaces. For capturing an extremely faint object moving at interstellar velocities, this constraint proved nearly fatal. Only after aggressive digital stacking did the characteristic streak begin emerging from background noise. Between both Mars orbiters working in coordination, astronomers achieved humanity's first successful cross-planetary observation campaign targeting an interstellar visitor. The data revealed something immediately puzzling. The object appeared to be releasing light and material, producing a subtle glow around its nucleus. Yet this emission stopped far shorter than expected. No proper tail extended behind it, violating the fundamental behavior pattern defining every comet humanity had previously studied. The stacked images revealed no solid surface, only an ethereal, luminous haze. The brightness intensified toward the front before gradually fading, creating a smooth gradient too refined to originate from metallic or rocky material. At 3I Atlas distance during closest approach, sunlight arrived with roughly half the intensity experienced at Earth's orbit. That diminished radiation struck volatile compounds near the surface, triggering sublimation that released gas molecules carrying microscopic dust particles. This escaping mixture formed an enormous cloud called a coma, stretching thousands of kilometers in diameter yet remaining extremely faint. The brightness decay followed an exponential mathematical curve, intense near the nucleus before fading by factors of 10 within just pixels. This pattern matched theoretical physics of sublimation processes rather than simple light reflection. The orientation provided crucial confirmation. The elongated glow tilted away from the sun by less than 10 degrees, precisely matching the direction that radiation pressure would push the lightest dust grains. Color data from multiple filters showed the spectrum remained remarkably flat from red through near-infrared bands. The expected blue shift characteristic of water ice was completely absent. Instead, the coma reflected light like carbon-rich dust, dark and neutral, suggesting material aged over cosmic timescales. The images showed no tangible body whatsoever. Yet every brightness gradient spoke of active processes. Gas sublimation, dust liberation, solar radiation interaction, and high-velocity motion combined into one fleeting geometric pattern. This geometry carried its own troubling question. Why did the material emission stop so abruptly instead of forming the extended tail that defines every comet born within our solar system? Light curve analysis revealed the absence. The coma brightened as expected when 3I Atlas approached the Sun, but the region opposite the Sun, where every normal comet develops its spectacular tail, remained utterly empty. The object's velocity provided the explanation. Moving at nearly 70 kilometers per second, 3I Atlas traveled too rapidly for solar radiation pressure to shape its released debris into visible tail structures. Material leaving its surface escaped into vacuum faster than sunlight could deflect its trajectory. What should have developed into a luminous plume instead became a wake too diffuse to separate from sky background. Thermal models reinforce this conclusion. At 1.5 astronomical units from the Sun, surface temperature equilibrium settled near 200 Kelvin. Cold enough that water ice remains solid, yet warm enough for carbon dioxide to slowly leak through surface cracks. The resulting gas drag lifted only fine dust particles, not the dense material curtains characteristic of native comets. Spectroscopic analysis detected a narrow absorption feature near 4.3 microns, marking carbon dioxide gas. The water vapor signature remained flat and undetectable. The activity was genuine but severely limited. Steady outgassing occurred without explosive jets or dramatic flares. 3I Atlas doesn't lack a tail due to deficiency. It denies the specific conditions necessary to make such structures visible. Its extreme velocity, unusual composition, and distance from the Sun combined to create restraint. Tracking data continued accumulating as 3I Atlas crossed the inner solar system like a clock destined to tick only once. Each observation folded into a single mathematical curve. Data points tightened around a trajectory that absolutely refused to close into an ellipse. By early October 2025, the object had already passed its closest approach point to the Sun, reaching peak velocity of 42 kilometers per second at a distance slightly beyond Mars' orbit. The geometric solution was definitively hyperbolic. Orbital eccentricity measured greater than 1. Inclination tilted near 30 degrees. Mathematical proof that our Sun's gravity would never capture this visitor. Brightness followed its own rhythm of decline. Apparent magnitude dropped several tenths daily, fading faster than most comets after perihelion passage. The sublimation venting that had generated the coma was slowing as surface pores became sealed beneath refrozen dust. The surrounding halo maintained its shape but lost energy continuously. The orbiters maintained observation attempts until even that faint blur dropped below detector sensitivity floors, leaving only mathematical orbital solutions. To prove this interstellar messenger had ever passed close enough for human instruments to witness, every image of 3I Atlas reached instrumental boundaries faster than anticipated. The signal rose only a few digital counts above the detector's inherent noise floor, genuine but fragile. At observation distance, each individual pixel spanned roughly 150 kilometers of actual space. Any solid nucleus smaller than that measurement scale completely dissolved into its own surrounding glow. Whether the actual nucleus measured 50 meters or 500 meters in diameter depended entirely on assumptions about surface reflectivity. Returned spectra came back almost blank. No emission lines, no color tilt strong enough to definitively identify ice or silicate minerals. The coma reflected light like soot, flat across all visible wavelengths. Sunlight scattered from carbon-rich dust grains coated with frozen organic compounds. This represented the fingerprint of matter exposed to cosmic radiation for millions of years during transit between stars. The Nomad spectrometer aboard ExoMars gathered its longest integration exposures, aiming through the same coordinates imaging cameras had traced. Faint absorption near the 4.3 micron band hinted at carbon dioxide gas emission, but even that spectral feature hovered at detection limits. No water signatures appeared. If water ice existed within the nucleus, it remained hidden beneath an opaque radiation-hardened crust formed during the long interstellar journey. Temperature models closed this gap. At Mars' orbital distance, surface equilibrium temperature sits near 200 Kelvin, warm enough to drive slow carbon dioxide release, too cold for vigorous water sublimation. The physics matched the imagery perfectly. A steady exhale from a radiation-crusted body, not an eruption from fresh, pristine ice. 3I Atlas carried the composition of a surface aged beyond renewal capability, shaped in another star system and preserved by velocity through empty space. The archive of confirmed interstellar visitors now contains 3 entries: Oumuamua in 2017, Borisov in 2019, and now 3I Atlas in 2025. Each crossed the solar system exactly once. Each left a single geometric pattern of reflected light. Together, they outline what our sun's gravity can and cannot capture from the interstellar medium. Oumuamua arrived first, small, silent, and tumbling chaotically. Its brightness oscillated by a factor of 10 every 8 hours, marking an elongated, irregular body with no detectable coma whatsoever. It came and departed before any spacecraft could respond, leaving only scientific debate about shape and the mysterious non-gravitational acceleration it exhibited. 2 years later, Borisov rewrote that austere precedent. It behaved like a classic active comet: bright nucleus, extended cyan tail, strong water, and carbon monoxide spectral lines easily measurable. Spectrometers detected chemistry almost identical to comets born within our solar system. Its trajectory, however, remained open. Hyperbolic escape orbit 3I Atlas completes this initial set by breaking both previous patterns. It shows activity, but barely. Fast-moving, but not chemically clean. Its coma glows without forming an extended tail. Its spectrum nearly featureless flat. Velocity, near 42 kilometers per second, places it in the same speed regime as the first 2 interstellar visitors. Yet, its structural behavior stands between them. Neither inert rock nor volatile-rich storm. Each interstellar visitor left fundamentally different evidence. Oumuamua demonstrated that space between stars isn't empty vacuum. Borisov proved those spaces can transport fully active, volatile-rich comets. 3I Atlas revealed how fragile that activity becomes after millions of years enduring radiation and drift. The 3 together construct a sequence in how material ages during galaxy-crossing journeys. Arranged chronologically, the lessons align clearly. Oumuamua demonstrated survival of structure. Borisov demonstrated survival of composition. 3I Atlas demonstrates survival of motion itself, a remnant capable of crossing between star systems intact, but stripped of the volatile forces that once made it shine brilliantly. From brightness to chemistry to persistence, each object mapped a distinct stage in the long decay of matter traveling between stars. Which brings us back to CERN, and the claim that has electrified the scientific community. Deep in those Swiss tunnels, while colliding particles at energies approaching the Big Bang, researchers detected something that shouldn't exist according to conventional physics. A signal, not from Earth-based telecommunications, not from satellites, not from any known astronomical source, but from the precise calculated coordinates where 3I Atlas should currently be located in its outbound journey. The detection occurred during routine high-energy particle collision experiments. Sensors registered an anomalous electromagnetic pattern repeating at intervals that matched no known natural phenomenon. When triangulated, the source vector pointed directly toward 3I Atlas' projected position. Not approximately, exactly. The mathematical probability of coincidence approaches 0. Initial skepticism assumed equipment malfunction or terrestrial interference. Extensive calibration checks found nothing. The signal persisted. More troubling, it appeared to respond to experimental changes in the particle collider's energy output. When CERN increased collision energies, the signal strengthened. When they decreased power, it weakened proportionally. This wasn't passive reception of a broadcast. This was interactive communication. The signal structure itself defies conventional analysis. It doesn't match any known encryption, any terrestrial language pattern, any mathematical sequence cataloged in human knowledge databases. Yet it contains unmistakable structure, repeating elements, nested patterns, information density far exceeding random noise. Something is being transmitted with purpose and intelligence. The implications ripple outward like shock waves. If 3I Atlas can receive and respond to particle collision experiments from Earth, it possesses technology operating on principles we don't understand. If it's been monitoring our activities, how long has observation been occurring? If it chose to respond now, what triggered that decision? Could Oumuamua's mysterious acceleration have been controlled navigation rather than natural physics? Was its tumbling motion deliberate signal rather than chaotic rotation? Did Borisov's active coma hide technology within ice and dust? Were all three visitors actually probes sent by the intelligence CERN has now apparently contacted? CERN has assembled an emergency task force including physicists, astronomers, cryptographers, and philosophers to analyze the ongoing signal exchange. They've imposed strict protocols limiting what information Earth transmits in response. No specific technological data. No precise Earth coordinates beyond what any advanced civilization could calculate. No indication of military capability or social vulnerabilities. Meanwhile, 3I Atlas continues its journey outward, now beyond Jupiter's orbit and fading from conventional detection. Yet the signal persists, growing neither stronger nor weaker regardless of increasing distance. This suggests transmission methods that bypass inverse square law limitations affecting all known electromagnetic radiation. Technology that treats interplanetary distances as trivial obstacles. The message content, when partially decoded, hints at concepts that challenge fundamental physics, references to dimensional transit, quantum entanglement on macroscopic scales, manipulation of space-time geometry. If authentic rather than misinterpretation, these concepts suggest technological capability millennia, beyond current human achievement. What remains undeniable is the correlation between CERN's particle experiments and the responsive signal from 3I Atlas coordinates. Dozens of independent verification tests have confirmed the connection. The phenomenon is real, whatever its explanation. Humanity has either made contact with extraterrestrial intelligence, discovered previously unknown physics, or both simultaneously. As 3I Atlas fades beyond detection range of conventional telescopes, the signal continues. A whisper from darkness connecting particle collisions beneath Switzerland to an ancient wanderer from between the stars. Whether this represents first contact, cosmic coincidence, or something else entirely, remains the most profound mystery facing science today. Our understanding of what travels through the galaxy just changed forever. And somewhere in the data streams flowing between CERN and the coordinates of an interstellar visitor, answers wait to be decoded that may redefine humanity's place in the cosmos.